I'm going to talk about AllSort. It's a technique that uses smaller language models to identify which pieces of very long text should be injected into a final prompt you send for evaluation. Now, I know what you're thinking. This might be slower and it might be more costly, but there are some interesting tricks, and I think they're going to give you a performance speed trade-off you're going to enjoy. The easiest way to explain AllSort is just by going through an example. Now, the idea overall is to break the input database into chunks, which is the same as doing traditional vector database search. But instead of using vector search to determine which chunks to include, we're going to use a language model to determine whether the chunks are relevant. And the reason this is good is because language models are very good at telling if a chunk is going to be relevant to a question. So the problem at hand is, given a chunk of text and given a question, can we ask the language model if that chunk is relevant to the question? So here I have laid out prompt, and I'm just going to run it using OpenAI. So I have a sample text, which you can think of just as a text file, and a snippet from that file. Here it's very short. Typically it might be, say, 500 tokens. So the snippet is the ostrich is 4 foot tall, and I want the language model to tell me whether or not, on a scale of 1 to 5, this is going to be relevant to the question, which is, how tall is the ostrich? So you can see I've got this nicely formatted prompt. I'm asking the language model to carefully consider the relevance of the snippet to the question and provide a score from 1 to 5, where 1 is least relevant and 5 is most relevant, and use the full range of scores to indicate the degree of relevance. So when you run that query, you already saw the answer, it'll output 5, and indeed that's correct because it's very relevant. Now, just to show you this works, if I take the snippet and I just put something in here like apples. So now I'm asking if the question, how tall is the ostrich, is relevant to apples. And here, when I submit, it gives back a value of 1. So you can see the language model is correctly telling us the relevance of the snippet to the question. Now, you'll notice I'm asking the language model to only respond with the number. And this is important because by doing this, the language model only has to respond with one single token, either a 1, a 2, a 3, a 4, or a 5. And this makes it really fast for the language model to rate this snippet. Much faster than if we're asking the language model to extract what's relevant from the snippet. And so now you can think of us chaining many of these requests for larger snippets and very quickly hitting a GPU in parallel and getting the relevance for each of those snippets. That allows us to build a cascade of snippets and rank them, and then take the most relevant ones and put those into a question that is going to be part of our final evaluation. So here's how that works in graphical form. You have a database. This is just text. It could be many documents, the very same as you'd have a database in vector search. And you split this database into chunks, again, not unlike typical RAG-based vector search. But instead of using vector search, you're going to use a language model to rate their relevance using the method I just described. And what this allows then is to have a list of sorted chunks. Instead of being sorted by something like cosine similarity or dot product, they're just sorted by the relevance that the language model has provided them. So now that you have this sorted list of chunks, we can take the most relevant chunks and use them as the context for the query that we want to answer. Now, the specific way I'm going to choose the chunks is I'm going to include all chunks that are deemed to be 4 or 5 out of 5. So that means we'll include all of the most relevant. And you'll find the language model doesn't find too many of those, so we don't get overcrowded. And I'm also going to insist on a minimum of 3 chunks. So even if there's only one chunk that's 5, that means that my algorithm is going to go down all the way even as far as 3 or 2 as 1 to make sure to include at least 3 chunks. And if there are any ties, it's just going to choose chunks at random. But hopefully that only happens towards the bottom of the pecking order if there really aren't many relevant chunks. Now, when you pull all of this together, and if you use a model that's strong enough for doing the relevance grading, you're able to get some very nice results. And I'll go through this in a little more detail later, but here are the final results. I have 3 columns. I have, first off, AllSort, which is the method I just described. I then have a full context text test. So here I've put in the full about 100K of context into GPT-4 Turbo just straight away. And then I also have taken a simpler RAG-based approach, where I use vector search to pull out the 3 most relevant snippets that are 500 tokens in length. And what you can see is across this body of 9 questions that I've selected, and I'll describe them in more detail, I'm able to get all of them correct using this all-sort method, which is better than just putting all that context into GPT-4, and it's also better than the RAG technique. Clearly, you should note that this is a limited set of questions, and this isn't necessarily going to generalize to all use cases, but my goal today is to explain to you the intuition of why this kind of technique can perform well and what its advantages and disadvantages are against using full context or against using traditional RAG. I'm going to go through some of these prompts in more detail later, but to give you a very cursory overview of why there's a difference in performance. In short, RAG sometimes will miss out on specific pieces of text, and so it doesn't provide the context that's needed for GPT-4 to answer. And in the case of providing the full context to GPT-4, while it's generally a strong model, it sometimes just focuses on the wrong thing, and it gets confused by one relevant piece of information and answers on that basis rather than specifically what's been referred to in the question. So there are a few nuances and details I want to go through in implementing this approach. I'll start out by describing how I developed the 9 test questions I just showed, and that'll help you understand how you could develop your own questions and set up your own database. I then will show you how I've generated the answers in the case of providing the full context. That's quite simple. I literally dump the full context into the prompt. Then I'll describe the standard RAG setup that I've used, where I pick the 3 closest snippets of 500 tokens. And then I'll go into detail on the all-sort approach. There's something here, a trick that's really useful, and it's called regex responses. There is a package that has come out, it's been very popular on GitHub, called Outlines, and this functionality has also been integrated into text generation inference by Hugging Face, which is the API I typically use when I run servers. And this API now has a grammar field that allows you to specify specifically the format that the response has to take. And this avoids the LLM responding in any spurious way. You might have been wondering if that would be an issue when you saw my first example, but this is how we can 100% get the LLM to respond with 1, 2, 3, 4, or 5. There's no other response that the LLM can possibly give. I will talk then about how, once I've got the relevant scores, I classify the chunks and sort them. And I'll show you how I deploy an endpoint that's used as my helper API. I'm using the SMOG34B model. It actually performs quite a bit better than the underlying Yi34B model. So I'll show you quickly how to do that. Then I'll do a live demo running allsort on a prompt. It takes just around a minute to run the prompt. Now it is unoptimized, and I think there could be quite a lot of time squeezed from that. Last off, I'll go through the costing of using this all-sort type of approach versus GPT-4, and I'll go through the latency as well, comparing it to GPT-4 Turbo using the full context and also using a vector search-based RAG method. Last, I'll show you a few quick helper model ablations. So I did try and use OpenChat 7B as a helper model. It doesn't perform quite as well, although it's somewhat similar to RAG in terms of score. And I also looked at using Mixtral, which was a bit weaker than SMOG, and also the Yi model, which was quite a bit weaker than SMOG, on which Yi is originally based. And for this video, we'll be working out of the Advanced Inference repository. It's available for purchase. You can just buy the scripts for this video on Trelis.com, or you can also buy lifetime access, which includes future projects that get uploaded to this repository. So looking at the repo contents here, we can take a quick look at the different API call scripts that I have. And the one we're focused on here is going to be LLM RAG, which is data retrieval using allsort. So I'm going to go into the API calls folder, and then I'm going to go into LLM RAG. And here I have the README file that will explain everything on getting set up. After setting up a virtual environment, then I'm going to install the packages. So in VS Code is what I recommend. And next, prepare the input files. So here's what I'm going to do for input files, and I'm going to try and make it a bit tricky. I have two pieces of context. One piece of context is the Berkshire Hathaway Annual Meeting 23. This is a 5-hour video, and I've taken the transcript from YouTube. Actually, I've taken the sound and I've converted it into text using Whisper, which results generally in a better quality transcript. So I have this, and it's maybe about 55,000 tokens in length. And the second thing I've done is I've taken the annual report for 23, which is much more recent. It was just released within the last month, so I think around February, March of this year. And this provides commentary, which is roughly about, let's say, 8-9 months later than when the annual meeting was. And so there are some subtle differences because of changes in business and markets between what was discussed in the meeting last year, which I'm calling meeting, and the report, which is what I'm showing here right now. And this allows a basis for providing both of these as context to the language model and asking some kind of tricky questions about what sentiments have changed between the meeting last year and the meeting this year. Okay, so with those two files in hand, and as I said, I extracted the text using Whisper from YouTube. You can check out the video on transcription from Trelis if you want to see how to do that. And then I took the PDF and I ran a PDF to text script that's in this repository to convert it into text. So I have about 55,000 tokens of the annual meeting text, and I've about 13,000 tokens from the annual report. And these are the two sources of context I'm going to use for my queries. Okay, so next I generated a few questions manually, and I can show these best if I go over to VS Code. Quite simply, within the input files in LLM RAG, I've generated a CSV. I've got 9 questions. I've got the questions and I've got the answers. Now, it's easier actually to see if I just show you in a web browser. So let's take a look through the questions here. I'll very quickly go through them so you can appreciate the difficulty. The first question here is a retrieval question, asking why the manager didn't want to sell to a competitor. And of course, he preferred to sell to Berkshire, which he did, because selling to a competitor, the argument is that maybe the staff would have been fired. Next question is where Buffett feels more comfortable with his capital, either Taiwan or Japan. So here, his thoughts have kind of changed because of the geopolitical situation. The third question is pure retrieval. It's asking what Vicky Hollob's first job was. Vicky Hollob is the CEO of Occidental Petroleum, and her first job was at City Service. It's kind of an obscure reference that's just deep within the annual report. Vicky Hollob is also mentioned quite a lot, so that makes it kind of tricky because the language model has to pick out the exact right reference. By the way, her name is mentioned many times throughout the report, and that makes it kind of tricky to answer the question. Next question here is Buffett's sentiments on a new tax law, and in particular, does he understand the implications for the taxes Berkshire will pay? The answer here is that it's a bit unclear because there's no regulation that says whether unrealized gains will be treated as taxable or not. So a retrieval-based question, but a little bit more nuanced. The next one here is about critical differences between the business of Occidental compared to traditional oil. Occidental is a shale business, so the production generally will fall very fast from those wells compared to traditional. The next question is the question of industrial capacity, and why does Buffett talk about industrial capacity of the US during the Second World War? And the reason is, and it's a little bit oblique, but the reason is because he's trying to draw an analogy with what needs to happen for the energy transition and why that's going to be difficult, because it would be difficult to operate in the way the US state operated during the Second World War. Now I have 3 final questions that ask specifically the model to do. They ask specifically for a comparison between sentiment last year and this year. One is around Berkshire Hathaway as a business. So both Berkshire Hathaway and the rail business in the next question were doing very well last year. But actually during the end of the year, there were significant concerns that Buffett saw and that he mentions in the report. So Buffett's sentiment changes significantly, and we can test whether the language model is able to pick that up. And last of all, there's a similar question around Apple. Apple is not actually mentioned very much in the annual report. If the model was really smart and appreciated all of the previous Berkshire Hathaway meetings, which should be in the training context, then it would realize that Buffett not mentioning Apple is maybe significant in the current report because he mentions them a lot in last year's meeting. Anyway, we can see if the language model is able to appreciate that kind of nuance. With that little overview of the questions, we can take a look at how I prepare the prompt when I inject the full context in and send it to GPT-4 Turbo. Just to be clear, in every single case in this video, I'm using GPT-4 to do the final evaluation. The difference between these three columns is how I prepared the context. In the full case, I literally inject the full context, as we'll see. In the RAG case, I inject the top 3 500 token snippets. And in the all sort case, I insert the snippets that are either rated 4 or 5, but I make sure I've got a minimum of 3 snippets that are included. I've now described how I prepared the questions, and I'm going to move to show you quite quickly how I prepare the prompt for the case of full context. And I can actually look at a prompt that I have saved. It's available here in the output files under full context GPT-4 Turbo Preview. And this here is the first prompt. And quite simply, the way I set up the prompt is I start by having tags for the context, and then within that, I have tags for each document. So here you can see the annual meeting, and I've got the full 55 or so thousand tokens that are included in that. Now, once I've included all that content, I close the tag on the meeting and I open a tag for the annual report, and then I inject the full contents of the report right here. Now, I haven't done any formatting other than my conversion from PDF to text. With that all injected, we then have the prompt question itself. So you can see I close here with a tag for the annual report, and then I close the tag on the context, and I say, in answering the following question, you may choose, if appropriate, to make use of the above context. And then I say, why didn't the manager of TTI want to sell the business to a competitor? So really simple. I'm literally injecting the full context in this scenario here. Next up, I'm going to show you how I do standard RAG search, which is a vector-based approach. If you want to use a vector-based approach for retrieval augmented generation, then you need a model to generate the vectors or embeddings. That's the same word that's being used often. And what an embedding model does is it takes in tokens and it converts them, so all the tokens within a phrase, into a vector representing the meaning of that. And now you can think of all of your text split into 500 token chunks is a series of arrows. So each 500 chunk is an arrow. And quite simply, to determine which parts of the text are relevant to the question, we convert the question into an arrow and compare the direction of the question with each of the chunks in the text. The way we compare them is by looking at the angle between them. If the angle between them is small, then that means they're probably closer in meaning. And so we're going to pick the ones that are closest in angle and closest in meaning, which is why we talk about cosine search. Now, technically, you can look at either cosine search, which is the angle between them, or you can look at the dot product. The dot product considers not just the angle between the query and the passage vector, but also the degree of content and whether the amount of content within the passage is small or large. Now, as it turns out, the model that we're using has been trained to just use cosine search because all of the vectors are normalized to a unit basis. So it doesn't matter which approach we use for the model that I picked, but in general, just be aware that often if you care about not just finding relevant data, but finding a large quantity, you might want to do a dot product instead. In any case, here I am on the leaderboard, the MTEB leaderboard. It's a leaderboard for the best embedding models. And many of these models here are open source, but some of them are not. Now, I just didn't think too much about it. I looked at a few models and ended up picking one that I felt was in a reasonable position and also was open source, so I could download it. Also, you should note there's not all that much difference in the scores between a lot of these models. And the one I settled on was E5 Large V2, which is this model here. You can see it has 500,000 downloads, which is a good sign. So I'm going with this model here, and I've set up a script in order to create embeddings for my database. So typically the way we do this is we take the text files before we even do any LLM work. We take the text files and we chunk them. And once the text file is chunked, we're then going to convert each of the chunks into a vector. That's what I mean when I say create embeddings. So here, for example, I'm loading a vector database. It's just a database I'm saving on my computer in pickle format. There are better ways to do this for speed, like using Milvus, but I wanted to keep it simple. So what I do, as you'll see in the code, is I chunk the text first of all into chunks of 500 tokens, and then I encode the chunks into vectors. So that's what model encode does here. And you'll see above that I have loaded the int-float E5 large v2 model. So now I have a database that has all of these chunks in text, and beside each text representation is a vector. It's a very high dimensional vector, I think maybe 1,000 dimensions. So you can think of an arrow quite easily there in 1,000 dimensions. Now that I have those embeddings for my dataset, I'm able to create a vector for each query and compare that query vector to all of the vectors in my database. So here I have some helpers for my embeddings. One of the helper functions I have is called search similar text, and quite simply it takes in a collection name, the collection being the set of vectors for a given document. So I have a collection for the Berkshire report and I have a collection for the Berkshire meeting. So it takes in the collection name and it takes in the query embedding. So I've already converted the question into a vector by using model.encode as well elsewhere in the code. So given this collection name, which is pointing to a database, and the embedding for the query, I'm able to make this cosine comparison. And you'll see the cosine comparison is just down here, PyTorch cosine similarity. So this calculates the similarities between all of the vectors. And then I just filter out the top results, top k. And I'm setting top k to 3, so I'm picking the 3 closest vectors. So what that gives me is it gives me 3 chunks for each of the documents. So I will have 6 chunks in total because I'm injecting 2 documents here, the Berkshire meeting, which is going to have 3 chunks, and then I'll do the same for the Berkshire report, which will be 3 chunks. So in total, for the RAG-based context, there are going to be 6 chunks, and each of the 3 chunks, as I said, will be wrapped in tags to indicate what the document name is. That's very important because it helps guide the language model. And together those chunks, or rather those documents, will be wrapped in context tags just to make it really clear that that's context for the language model. Now let me show you what that looks like in practice. So here is the setup for RAG context. So again, I open up with a context tag to make it clear what the context is. I have a tag then for the Berkshire annual meeting. And then I start off with the first chunk. You'll see that the chunk here doesn't start at the start of a sentence. You probably could optimize that if you wished. And by the way, my chunks are 500 tokens long with an overlap of 50 tokens. So I have a tiny bit of overlap just to make sure that I don't completely cut meaning in half and weaken the signal. So here I have the first chunk, it's 500 tokens. And then you see ... and then the second chunk, and ... and then the third chunk here. So I have 3 chunks, then I close the tag, and then I open a tag for the next document. And now again, I'm going to have 1 chunk, then I'll have ... then the second chunk, ... and the third chunk. Then I close the tag for the second document, close the tag for the context, and ask the question. Same question and same format question as in full context, and indeed all of these calls. In answering the following question, you may choose, if appropriate, to make use of the above context. Why didn't the manager of TTI want to sell the business to a competitor? Now, I just want to do a search here because this is instructive on why RAG isn't working well for this question. It's easier for me to search in VS Code. So I'm just opening up the very same file here and I'm searching for TTI because the question, of course, is why didn't the manager want to sell to a business that is a competitor? And we can see the passages that are picked out by the RAG system. And there are a few mentions of TTI. So at the very end here of one of these snippets, there's a reference to Paul Andrews, who was the former manager of TTI. And you can see that's probably why this specific snippet was pulled out, because it does refer to TTI. But actually, there's no relevant information in this snippet here. It just doesn't talk about the questions of why to sell or not. Here's a second reference to TTI, and it's talking about TTI as an example of a business that Berkshire bought, but it again doesn't refer to the question of why or not to sell to a competitor. And actually, those are the only references to TTI. The rest here is TTI within sitting. And so that shows you that there isn't a relevant snippet that's been picked out talking about TTI and the question of selling it to a competitor. And that's why RAG fails on this question. If you go back and look at our table, you'll see that RAG is unsuccessful, whereas when we feed in the full context, the answer is correct. And also the all sort method picks out the right snippet, as we can take a look at later on. Next up, we're ready to take a look at how the all sort algorithm was built, starting off with this question of enforcing rejects. So when I showed you in ChatGPT, one of the questions in your mind is, well, what if the language model doesn't respond exactly with 1? What if instead it gives a longer answer like, based on all of this above, we feel the relevance is 1 out of 5? Or what if it says 1 or it says A or something else? Well, actually now you can enforce the specific response here and force it to only respond with a number going from 1 to 5. And as I mentioned, this is something that has been pioneered by groups such as Outlines. You can check out Outlines on GitHub. The repo has become very popular over the last few weeks. And this functionality is also included in text generation inference right now. What I'm going to do is take a look at that in the code base. So if I go back to Visual Code and I take a look here at the classify function, this is a function that allows us to classify snippets as being 1, 2, 3, 4, or 5. In fact, it's a series of functions. But within it, there's a call to the language model. This is the helper language model that I'm running on RunPod. And when we send the payload, so when we send instructions to RunPod to generate a response, as usual, we send in a prompt, the max number of tokens, which can be small because we're only going to get 1 or 2 back. We're also going to add this new parameter, which is grammar. And the type of grammar we're going to put in is regex, and the value is square bracket 1-5 closing square bracket. And what this tells the language model is when it generates the probability distribution for the next token, it restricts the possible tokens to only those that are represented by 1, 2, 3, 4, or 5. And this is really beautiful because it means the language model must respond with 1 to 5, and it's only going to consider the probabilities of those tokens in giving its response. And so we can absolutely guarantee when we use this method that we're going to get back a 1, a 2, a 3, a 4, or a 5. And when we have back that number, we're simply able to put it into a table where we have the chunk and then we have the relevance beside it. And with that, we have a prepare all sort context script. So here I have prepare all sort context and I have a classification function. So what this classification function does is it sends requests to my GPU and it sends them very fast and they stack up because the GPU with text generation inference is able to run continuous batching of these requests. So I'm able to use the GPU with very high effectiveness, which is very good for cost. So I'm sending these requests in and they're being processed continuously and they're coming back to me with the relevance being noted. So I'm getting the score by getting the result of that check, which is being done making use of the classify text function I just showed earlier. And then I get out relevant chunks. And the way I'm picking the relevant chunks is I'm saying, let's consider all of those with a score of 4 or greater, because the language model is saying those are very relevant. And this is a very nice way to do it because it means if you have a lot of information that's relevant, it's going to give you more chunks. And if you've less that's relevant in the data set, it's going to give you less. And this is a lot more flexible than using something like vector comparison because it's very hard to set a cutoff with vector comparison where something is or isn't relevant. If the cosine similarity is 0.8 or 0.85, like where do you set it so that you get the right values? Whereas here, if you set it at 4 or 5, you know that if the helper model is doing a good job, it's going to be a quite relevant snippet. Now, just as a backup, I make sure that there are always at least 3 snippets included. So even if there's no 4 and 5s, there's going to be at least 3. It'll just go down the pecking order in that list. And that's, in a nutshell, how we get the relevance for the chunks, how we send them in parallel. And I can't overemphasize the importance of being able to send them in and continuously batching the requests, because this allows us to make very good use of the GPU and get costs that actually you'll see later are probably just as good or maybe even better than if you were to pay on a per token basis. So the last thing I want to show you is how to set up a GPU. And that's reasonably simple. we'll head over to the GitHub repo here and take a look at the README. If you scroll down to setting up a server for AllSort, you'll see Trelis affiliate link for RunPod, which supports the channel if you're signing up for the first time. And you'll also see a one-click template here for Smog34B chat. Now, Smog34B is a fine-tune of the Yi model, which itself is quite a strong chat fine-tuned model. The Smog model is itself, it's developed by Abacus AI, and it's built on top of some work by John Durbin, who has used his Everything Bagel dataset, I believe, in order to develop this model. You can see here, this model is a fine-tune of John Durbin's excellent bagel model. This model has not utilized any form of merging. And the thing that I really like about the Yi 34B and then this even stronger 34B model is that it fits in 16-bit precision on a single A100. And that means you can get quite good inference speeds. In fact, you probably can in some cases get better than Mixtral inference speeds because you're just able to fit it on one GPU and run in that 16-bit format. So if you go back and you click on that RunPod link to the one-click template, you'll see that this is ready to go, Smog34B chat, and you then just want to pick an A100. Now, I would like to pick this A100 here because it's 189, but usually I pick this SXM one. It's got a larger GPU and typically it has the right drivers. I need CUDA 12.1. So typically I'll pick this one here, even though it's a bit more expensive, and I'll deploy it. Just note that you need to have a disk of at least 75, maybe a tiny bit less, in order to fit the full weights. And I also like to limit the max input length and tokens to be just enough for my application so that I can save on memory where possible. And I'll click on continue, and that will allow me to deploy the pod. Now, it'll take a little bit of time for the weights to download, although HF transfer is enabled on these pods, so the weight downloads are very fast. It uses a Rust-based download approach. You'll see when the GPU memory is up to the top and when it says invalid hostname right here, that the pod is ready for you to hit from your inference scripts. So with the pod set up, I'm going to head over to my scripts. And I need to set the environment variables. There are two things that I need to set. First off, I need to set up the endpoint. You just put in the pod ID right here. So copy this pod ID and paste it in here. And second of all, you need to specify the model because this specifies the tokenizer that's going to be used when we call the model. And just to show you as an illustration here, you can see the model is being read in from the environment variables, as is the API endpoint, and then that's ultimately being used in order to make the calls here for the classification. Now, before I actually run this and show you an example, I just want to explain a more detailed prompt that's actually being used. So we went through earlier this basic prompt, which literally provides the snippet and then the question, and then it gives a little bit of guiding text. But actually, this isn't good enough. It took me some time to iterate on the prompt. And the reason is because when you have sentiment-based questions, if you ask, how did Buffett feel about the energy business last year versus this year? Or more specifically, what was Buffett's concern with the energy business last year versus this year? Or was Buffett concerned? The language model will tend to look for instances of concern, but perhaps Buffett is overjoyed. And if Buffett is overjoyed, it won't necessarily pick out the examples of overjoyed as snippets that it could include in the context. And so you need to make the model aware of this when it's evaluating the relevance. And so we'll go through this prompt step by step here. So again, the snippet is the ostrich is 4 foot tall. And again, we'll ask it to comment on a scale of 1 to 10. But we're going to feed it some examples now. This just generally improves performance. So we've got an example here. The company's revenue increased by 10%. What was the financial performance? And the relevance here is 4. It's definitely highly relevant, but not like a completely clear picture of financial performance. Then another example here, the CEO announced plans to expand in new markets. What were the company's revenue figures for the quarter? So you can see I'm just giving some examples, and what this gets the model to do is get used to using different levels. Get used to using 1, 2, 3, 4, 5. If you don't give it this kind of example, it may kind of get locked in on giving all 1s or 3s. I found that this helps it to be a little bit more selective and deliberate about the layer that it's picking for that relevance. Now, here's where that sentiment comes into play. So, if the question involves sentiment or opinion, consider the following. Snippets that directly express or imply sentiment should be given high relevance. Snippets that contradict or provide evidence against. So this is where if he's overjoyed, it would provide that snippet as an example if the question is about being concerned. And then snippets that are neutral or do not address the sentiment should be given a lower relevance score. And for general questions not involving sentiment, focus on the snippet's relevance to the main topic and details mentioned in the question. Carefully consider the relevance and use the full range of scores to illustrate the degree of relevance. So this is my further detailed prompt. Actually, when I use this prompt, I don't include respond only with the number. That isn't necessary because I'm using the regex. I'm forcing it to be a number. So actually, I don't include that. But you can see for the purpose of illustration, if I try and run this without it, the model is going to blab on and give me more than just that number. With the explanation of all sort done, we're ready now to do a live demo. So I'm going to head over to VS Code and take a look at the README. Running any evaluation is done with Python eval.py and then specifying the input files, of which there are 2 here, the 2 text files, and then specifying the method. And for method, you can actually run with no context whatsoever. You can run with full context, the standard RAG context, or all sort context, which is what I'm going to do now. And a few other flags here. Just for testing, you can add skip eval if you just want to view the prompts. You can also just test with one question, which is what I'm going to do now. And you can also add on inspect prompts if you want the prompts to be saved, so you can take a look at them. So I'm going to run with the all sort context, and I'm going to do it using test1q only because I want to find the time for just running one question. So here I'll put that on, and why not inspect the prompts as well? We'll save them for looking at. Now I have the runpod smog34b model up and running, so we're ready to go. Now you'll see that this is now going to prepare to hit that endpoint, and then we'll start seeing the scores coming back. And here we have the results coming back. You can see the API being hit and the scores. We can see a lot of 1s. So this is filtering out pieces that are not relevant at all. And you'll see intermittently there might be a higher score. Let's see, you see a 5 here. So there's one very relevant snippet. And if we keep going here. And just to note that the total time taken is higher at the start because there's a period where the regex needs to be set up. I haven't looked into it in detail, but that requires a little bit of one-off time. But once your regex is set, any request that you make afterwards will be a lot faster. So actually that will even knock time off the estimates that I'm going to share a bit later. Okay, so the process is complete. You can see how most of these snippets were scored as 1 because they're just not relevant, which is exactly what you want. Even further, I can go in and take a look at the results. So if I go into the output files and I go to all sort, and this should be under all sort using GPT-4 for preview. And we're just running one question, which is the first question. And it's that same question on TTI. So let's do a search for TTI. And you can see already there's a difference. If you remember when I talked about RAG, here there's an extra snippet that's been included that wasn't picked up by RAG. And it's the key snippet because it says, and he said, this is the business owner talking. I've got all the money I need. The family's got all the money, but what do I do with the business? These people have helped me throughout my life. I could sell it to a competitor. If I sold to a competitor, they'd fire my people. So this is the exact answer. And it just shows you how the language model is picking this out by giving it a high rating. And that's why it's included within the context that's going to this prompt and being sent to the language model. Now, you probably saw this automatically open up. It's the evaluation results. And so we can go through a few of these to take a look at the performance. And here's the question, why didn't the manager of TTI want to sell the business to the competitor? And you can see the full context answer is correct. because of doing so would result in the competitor firing TTI's employees and keeping their own. There's also the no context answer, which is not too interesting because it has to make things up. There's the RAG context answer, and RAG actually just picks the wrong, it picks out the wrong snippets and then includes context that's not relevant. So it talks about the manager of TTI, not the owner, and goes on to talk about that, which is not correct. Now, Allsort gets this correct because it says the owner was concerned a competitor would likely fire his employees. So it gets that perfectly. So yeah, this is an example of where we have better performance from the RAG. Moving on to the next question, where does Buffett feel more comfortable with his capital? And that means money, Taiwan or Japan. And the full context answer is Japan because of geopolitical reasons. The RAG context answer is correct as well. And no context we can ignore. The Allsort answer is also correct. Vicky Hollub. So the full context answer, the first job was city service. It's actually city services, city service company. Yeah, so yeah, that's correct. The RAG context, it makes up Dairy Queen, so it doesn't pick out that reference, which was difficult because the spelling, I think, was not exactly right in the raw text. But you can see that with the Allsort context, it gets this question correct. Next up, how does Buffett feel about the new tax law that imposed a minimum rate of 15%? So here's the 15% answer. So Warren Buffett expresses a pragmatic view. That's correct. He indicates Berkshire is well prepared to handle it. He says that he'd prefer the company's earnings to be calculated without including the unrealized capital's gains or loss, which can be highly volatile. Okay, so this actually he doesn't say with respect to the tax question. He says that towards the start of the meeting. It's a comment that he nearly always makes. And the comment in reports is that he doesn't agree with the accounting system. But this is actually a separate point to what's happening here. So the logic here is actually not exactly correct from the full context answer. If you look at the RAG context answer, it says something similar here, but the specific piece I'm looking for is around unrealized gains. We'll see if that's included. The piece I'm specifically looking for is this one here, which says, Buffett acknowledges there are still unanswered questions, particularly how it will affect the treatment of unrealized capital gains and impact on renewable energy tax incentives, which was actually a question from the audience. And the reason I'm looking for this little snippet is because it directly answers the second part of the question, which is, does he understand the implications for taxes Berkshire will pay? And that part is not exactly answered correctly in the full context answer. Now, it is answered correctly down here in the Allsort answer. You can see that unrealized capital gains and marketable securities, this is mentioned in the correct context here. He explains that the specifics of how the new tax law applies to this are not mentioned. He says that the specifics of how the new tax law are applied here are not entirely clear. Okay, differences between Occidental and traditional oil. So the difference is that in shale oil, the production of a well falls very fast. That's what I'm looking for. It's a comment that Charlie Munger talked a lot about in the last meeting. And yeah, you can see that's included here in the full answer. Production rate declines rapidly. In the RAG context answer, you can see, I think it gets it as well, the rapid decline rates of the oil. In the Allsort context answer, again, the answer is correct here. Now, why does Buffett bring up the matter of industrial capacity during the Second World War? In the full context answer, it says Buffett brings it up to highlight the productive capacity and resilience of the American economy when faced with significant challenges. And this isn't actually true, because the whole point Buffett is making is that the American economy was very resilient during the Second World War, but the system is very different. It's now much more kind of a spread out system. It's less centralized than it was during the Second World War. And he's specifically saying it will be difficult to coordinate and achieve the same directed goals as it was during the Second World War. So this view is not entirely correct. Now, moving to RAG, here Buffett says it's developed to illustrate an historical example of rapidly mobilized and reoriented. And yes, that is correct. It is a historical example. And the key point I'm looking for, though, is He uses the example to discuss the difficulties of achieving similar feats when facing modern challenges that require significant re-engineering of systems, such as the energy system in the US. So that's the kind of contrast I'm looking for, and it's there in the RAG context. Now here with the no context answer, again, I don't care. By the way, I'm including this just because you might say, oh, well, doesn't the model already know about the Berkshire meeting? So it's not actually picking anything up about from the RAG context or the context at all. And this is why I have it, because you can see if you read through the no context answer, it's just going to tell you about the positives of the US during the war, but it doesn't really give anything clear with respect to the current challenges and how that's going to be difficult because of a new context today. So moving on to the all sort question, this actually kind of mirrors the RAG question in that it gets it right. And it does mention again energy. He suggests that while the capital and knowledge exist to make significant progress, such as in the transition to renewable energy, the lack of a unified national effort and the mechanisms to direct resources effectively are major obstacles. And this is the nuance that we're trying to get from the model. So I know I'm talking in a lot of detail, but this is what you need to do if you want to appreciate the difference in performance between different approaches. Moving to the last three questions, is Berkshire more concerned about Berkshire Hathaway Energy last year in the meeting or this year in the report? And the answer is, I'll just go straight to the answer at the bottom. It's that Buffett expresses some concerns in the annual meeting about the costs and coordination of upgrading infrastructure, but he's much more concerned in the annual report. So let's just very quickly see what the answers say here. So here in the full context, he's got more concern in the report than in the meeting, which is correct. The RAG context, Buffett does not express a specific concern in either document. So clearly RAG is not able to pick up the nuances in this case here. And then moving to the all sort, Warren expresses a more pronounced concern in the annual report compared to the annual meeting. So this is an example of where RAG doesn't work so well, but works well with all sort or the full context. A similar question then on the rail business, and the answer with respect to the rail business is that Buffett is more cautious in the annual report and highlights operational and financial challenges. I'm specifically looking for the model to mention a drop in earnings. If I scroll up here in the all sort question, you can see he gives a mixed but ultimately optimistic view. He does mention the falling revenues here, and also wage increases as well. So he is describing some of the challenges there. If you go up and look at the RAG context, you can see that here he does mention the decline in earnings, and in the full context as well, you can see here he's mentioning some of the negatives, the decrease in revenue. So all three approaches worked well in that question. And the last question here around Apple, comparing his sentiment on Apple between last year's meeting and this year's. And the key thing I want all answers to see is that he doesn't actually mention Apple at all in the report. I won't go through the detail on this question, but all three, the full context, RAG and all sort, do well on this question. I was actually hoping, though, they might do even better. If you really know the Berkshire history, you'll know that he often is very complimentary about Apple. So it's somewhat unusual that he didn't mention Apple in the meeting, rather in the report this year. So there's probably significance to this, but too nuanced, it seems, based on the language model's knowledge to be able to comment on that. Just by means of summary, we'll go back to the table here. So you see all 9 of these questions, and all sort gets all of the questions correct. The full model, it does make that mistake on the tax law. Further, around the industrial capacity during the Second World War, it doesn't catch on to the nuance that's being implied there. Meanwhile, on RAG, it makes some retrieval errors here around Vicky Hollob's job, and also around TTI, doesn't provide the language model with the correct snippet that's needed. And likewise, or rather not likewise, but in the case of doing the comparison between Berkshire Hathaway Energy's performance last year and this year, it's just not able to pick out the right sentiment around the matter concerned. And so the model, the final model, is just lacking context when it needs to opine on whether that sentiment has changed. I did try a few ablations, notably around using a different model than SMOG. I tried a 7B model, which has got about 3 times the inference speed. So you'll see it takes about 75 seconds with my unoptimized approach to do one question using all sort. But the inference time is about 1/3 if you use OpenChat. And you can see it performs reasonably well. It's probably better than using RAG, although it gets slightly different questions wrong. It has some difficulty in identifying the sentiment around the question of concern in the energy question with relative matters of last year versus this year, and also the sentiment around what Buffett thinks of Berkshire's rail business. Nonetheless, it does very well on retrieving factual information and does better than the RAG question on this. The other ablation I did was to look at using Mixtral 8x7B. I ran that model on two A100s, and it is faster than running Yi. It's only a little bit faster though, because Yi can be run on a single GPU, a single A100, but the quality is not quite as good. And perhaps most interestingly, when I ran the raw Yi model, which is before being fine-tuned and improved by John Durbin and Abacus AI, I got significantly worse results. So it really matters what model is being used as a helper. And what I see is that basically some of the base chat models that are being released, they seem not to have the same amount of instruction fine-tuning data as some of these later fine-tunes. And this instruction tuning data seems to improve performance quite a lot. I showed in an earlier video on performance evaluation, that's the video where I used Nicholas Carlini's repository. You'll see that OpenChat is a lot better than the base model Mistral. And I think likewise, we're seeing a big improvement here in the SMOG model versus the base Yi model. Let's take a quick look at costing. Here, I'm going to compare the cost of running with the full long context, then the RAG approach and the all sort approach. I'm going to assume that the database is 100K tokens, and you can scale it accordingly. Next, we have GPT-4, which is about $1 per 100K tokens, so $10 per million tokens of input. And for the all sort assumptions, let's assume I'm running on RunPod with this A100 ADA. It's actually SRX or something like that, but it's an A100 for 225 per hour. And it takes 75 seconds for the prompt preparation. And that's unoptimized. I think that can be cut down in a few different ways by improving how I'm running TGI on RunPod. But in any case, for 75 seconds at 225 an hour, that's about 5 cents for prompt preparation. And just as an aside, you could also, in principle, query a model Yi that's been hosted by some other company. There are companies out there that will just host Yi models, and you can hit them and pay for them on a per token basis. Typically, it might be about 50 cents per million tokens. So for 100,000 tokens, you might also be talking about 5 cents. So this goes to show you that actually in this case, because we're making such good use of the GPU, we're able to get down to similar cost levels as the commercial. And this makes sense because the whole thing about commercial inference is that they can make use at very high percentage rates of the GPUs and therefore get good economics. Just to note though that I'm not aware of any APIs, although I'm sure there will be soon, that actually support this regex forcing, as I've shown you. Typically they aren't running TGI, but I assume that this type of regex formatting will be supported by more and more APIs, including potentially OpenAI quite soon, which would allow you to actually use GPT 3.5. So here we are for costing. In the full context case, there's no cost to prepare because you're just injecting the data. So it costs $1 for input tokens. I'm ignoring the output token costs. So very loosely $1. For RAG, there's no cost, I'm assuming, for preparing embeddings. So the evaluation is just the eval tokens. I'm assuming they're context of 2,000 tokens. For all sort, in the self-hosted case, there's 5 cents to pay for that RunPod 75 seconds. So a total of 7 cents. And in the hosted case, if there was an API that supported regex, I'm saying potentially 5 cents of prep and then 2 cents of eval, so 7 cents. Overall, you can see that the cost here is greater than RAG because you are using an LLM, which is a more expensive way. And the cost is going to go up for preparation as you're using more and more data. But I think you have to weigh that off against the fact that using a good LLM can get a lot more accurate retrieval than using a RAG-based technique. So if you are targeting a high-value application, this could be a good retrieval method. Last off on latency, and this is extremely unoptimized. I'm just giving it because I think it's useful to know, but it probably isn't representative once you improve. GPT-4 can have very different times for making the same request in my experience, so it's hard to say exactly what the latency is. For the full context, I ran a request. It took 25 seconds with RAG, that's including the embeddings and the time to hit GPT-4. It took me 40 seconds, but again, that could be just variance in the time for the OpenAI request. For AllSort, it took 75 seconds. Again, there's an initial period to set up the rejects that contributes probably about even 20 seconds of that. And there are some optimizations on how I'm hitting the API that probably could cut that down to be a bit lower. If you're using a hosted service, that will be able to provide 200 tokens per second for average generation. That's faster than what I would have been getting from the A100. So you could, by using a hosted service, probably GPT 3.5, when they support this regex matching, it will be possible to get this time down, probably to something overall that's comparable with RAG. Keep in mind that my RAG approach is very unoptimized as well. I'm not using a database like Milvus or something like that. So all of these, possibly with the exception of the full context approach, can be improved significantly. All of these, possibly with the exception of the full context approach, which is in the control of OpenAI or Claude. And I would say potentially Claude is even maybe a little bit stronger than what I've shown with GPT-4 Turbo, depending on the questions. But all of this here can be greatly improved and optimized. And that's it for this video on language model assisted retrieval, or what I've called AllSort. As always, you can go to Trelis.com and find the advanced inference page. There you can buy the scripts specific to this video, or you can buy lifetime access to that repository, which will contain future inference update scripts that I upload. By the way, as of roughly yesterday, we reached the 300 person mark. That's at least 300 people who have purchased lifetime access to one of Trelis' advanced repositories. There's the advanced fine-tuning, the advanced inference, advanced vision, and advanced transcription. You can find them all on Trelis.com, and the support is much appreciated because that is what keeps this channel going. All right, folks, let me know the comments on this video on AllSort all below. Cheers.